Thanks a lot for the introduction, and indeed the question, what is real world, is well, we tend to raise a lot of philosophical questions on this conference. What is intelligence was the main question of yesterday, so I think there's no problem answering what is real world. Since we have a lot of people from academia here, and it's kind of a unique event when you actually have so many people from academia coming to industrial section. And apparently for me, applications of machine learning in real world start from great educators that give expertise to the people who become industrial leaders. So the first question that I would like to ask is, for you within your companies, or generally out of your experience, which interactions between industry and academia, but for wonderful conferences that you can organize, do you know of that were successful and maybe fruitful? So in which format do you like to work? Do you have certain programs with academia and so on? Yeah, so we work in a very free format. Whenever you have something to say, just say it and that's it, yeah. So, any volunteers?
Okay, happy to start. So, very quickly about myself, I'm Emanuele de Leonardis, and I work for Orange, which is a global telecommunication operator, and my role consists in working with enterprise customers to imagine new data analytics products that we can take to the markets. I'm very focused on B2B. So to your question, Ivan, we actually have quite a large R&D activity within Orange, and we have a lot of collaborations with academia and all over the world. I mean, mostly French, but not only.
Yeah.
So we either have, let's say, direct relationships with academia, and that we do have a number of projects going on, or we do get together on European funded projects. And
so this is Horizon 2020 framework or something like that?
Yeah,
okay.
And not only, yeah. I mean, we actually have always done it this way, working together with the universities on projects. And typically, for example, if I know that a couple of examples of projects we're working on at the moment with academias. So, for example, there is one called NetLearn. And as you can imagine, the biggest problem for mobile operator is how to make sure that we provide the best customer experience while optimizing the way we manage network resources. So that's an ongoing issue for mobile operators. And at the moment, we're working on this project with Paris Tech, Telecom Paris, which is a famous engineering school in France, and also with EMEA, which is a public research institute. And what we are trying to do is to study, design, develop, and validate algorithms, learning algorithms distributed that can help us manage network elements in a better way. I mean, I can elaborate more if you want.
Well, I think we have several other gentlemen that want to elaborate as well, so yeah.
Well, let me start with an introduction. I'm Reza Khorshidi from AIG. I lead the quantitative analytics team for Europe, Middle East, Africa, as well as Special Projects Lab. Both these teams are part of what the department in AIG called Science. So Science is led by Chief Science Officer, member of the board. So generally, the role that Science has is, as the name implies, to bring state-of-the-art science that could be the hot topic in academia or elsewhere to AIG. A big part of it happens to be data science, but it's not just data science. As a result,
could you close?
As a result, academic collaboration of different types is a very essential part of our day-to-day work. And it normally happens in different ways. Some of the people in the team already are half academic, half industrial. Like I myself, I'm an adjunct professor in Oxford, so I spend some time in Oxford on biomedical informatics and machine learning. There are other people there who are professors at NYU and other universities. So that's a way things happen. Another way it happens is that we have got people who are former PhD or postdocs from top universities. So they happen to naturally go back to their supervisors or lab colleagues or whatever for Q&A, for advice, and so on. Then there are more official versions of these sort of collaborations where basically we sometimes fund on small companies that come out of academia. Sometimes we fund pure academic projects, such as, for example, how to inverse a big matrix is a project we fund.
Oh, that should be very interesting for
no, but I mean, it's like
the people in the audience. Yeah. I mean, how do I fund a project on inversing a matrix?
No, I mean, like
I go to AEG.
Inversing a large matrix is a very pure academic problem. Even we go that far. But there are plenty of projects that could be shared, could not be shared, that we work with academia. And also, we are trying to play a little bit of an active role in a lot of academic circles. For particular, I can talk about myself in the UK. Like, for example, recently they launched Alan Turing Institute for Data Science.
Okay.
So we have been invited to the core scoping events, and we try to play an active role. So insurance industry's needs are going to be reflected there. So it's quite a broad set of versions of this academic industry collaboration that we advocate, and we are open to new ones if there is interest.
If there is anybody interested, yeah. Okay, yeah. It seems that we'll have to kind of go from one side to another. Apparently, a lot of people have. Yeah.
That's common.
Okay. Yeah.
Yes. My name is Jochen Glaser from Intel, responsible there for sales in EMEA. And I mean, as you can imagine, we are doing a lot with university science together. So there's a lot of development going on, and also in the company, you know, we have many students, many interns, where we have collaboration close together with universities. But it's going even further because we also have a good relationship with many of the top universities in the world when it comes to technology like supercomputing, high performance computing, also in regard of big data analytics. I've seen outside, you have the example CERN, right, where also Yandex is involved. I mean, that's one of our biggest partners as well as customer in this area. So there's a lot going on, and especially, you know, with the newest technology for the future, that Intel can provide the technology to make this happen at the end of the day, that we have and are able to analyze all the data and information which is exploding at the moment.
Okay.
Yeah. So probably just a bit of background. So I'm heading the machine learning team in Amazon, but I've worked for a bit over a year at Facebook in applied science position and 11 years at Microsoft Research. So I've seen a few of those models at work. I think one of the things that's common to industry is that industry has a lot of problems and academia has a lot of solutions. So I think where industry can help academia is focusing the research on the practically relevant problems. And the other thing is, I think the interactions have to fit in the cycle of the sort of progression of an academia. So internships, I think they work very well because in an internship, a person that works in the department gets a glimpse 3 months what an actual practical problem is. It gets a person gets access to actual data at scale or at the complexity, because data is often also, like I remember when I was doing my PhD in Berlin, data was a clean, fine matrix of data. You know, the rows were the records, the columns were the features. But in reality, data is it's sort of very dirty, and it's in log files, and it's not joined, and that process is completely abstracted. And you kind of think, when you think of algorithms, you start at the wrong point, you start at the wrong end. So an internship can really reveal that in all sorts of applications. I think another one where it fits very naturally in the life cycle of sort of an academic person is postdoc. So a year where you're not committing to an academic position or industry position, or up to 2 years, but you explore, and you've proven that you can advance state-of-the-art independently. So I think that's something where industry and academia can work, offering postdoc positions.
There's also the field of data in itself, because academia tends to have a constant lack of data for certain tests and so on. And some industries, at least, like I'm coming from finance industry, and in finance, like companies tend to protect a lot of their data, which is understandable. It's part of their core business.
I think that's a tricky point, because I think often you hear that universities and academia would like to have data, but the data doesn't belong to most companies. It belongs to the customers of those companies. So whether you're at Facebook or you're at Amazon or you're at Yandex or you're at Microsoft, the customers enter search queries or they share very personal things. It's their data still. It's not the company's data. And so that one you can't really share. But the problems, I think, often lie more in the models you need to build for that data, because the data is never as clean as any of the textbook algorithms that we've heard about. The moment you arrive at a matrix inverse problem is a good one, but you've had done 80% of the work before that. And 80% of the innovations probably happens before you're at the matrix inverse problem.
Okay. The next question is more like the issue of Like you can speculate on that, and that's totally all right. But there is a great example of graph theory that used to be a purely like pure mathematics 10 years ago. People liked it. A lot of people worked on it. It was a very interesting field of mathematics, but there were not a lot of applicable solutions available to a daily user or a daily customer that were based on graph theory. It was considered like a very interesting field of mathematics for pure mathematicians. And then boom, something happens, and in 10 years we see that it's actually a factor that's very important for a person who wants to work in the field of data analysis, the field of knowledge that's in a high demand. So do you see maybe now, out of your expertise, some fields of knowledge that are growing now at the moment, like not trending, but are on their start, and maybe you feel the growing demand for certain people working in certain field or understanding certain mathematics or certain engineering problems that maybe are not so highly rated now, but probably going to be very important in a year, 2, 5, whatever, something like that. Yeah. So maybe we'll start. Yeah, out of the way.
So
Just.
Okay.
Yeah. Sorry.
So I think it's a super interesting question and very hard to answer because there's a good chance of being wrong, and then you're recorded.
Sure.
But that's okay. I think 2 areas I see that become more and more interesting that are not mainstream today, and particularly not machine learning, is functional programming and hardware developments. And the main reason is I think that scale is the challenge here. Like we're at the stage where not just a few big companies have the scale that you can't execute machine learning on single machines. You have to think distributed, or you have to think either subsampling the data or minimizing the amount of physical time you spend on processing a record of data. For distributed compute, I think the notion of stateless languages that have stateless compute, like functional programming languages have, pure ones, really are the most maintainable way, and they've been overlooked. They didn't have a killer application, but when you look at kind of applications of Haskell lately in the last couple of years, or OCaml, or F#, I see that on the rise, and I think we see more like there's now a field called probabilistic programming, which is a way to build machine learning models through a programming language that's emerging. The other one is when you look at the sort of the second coming of neural networks, it's not because the algorithms have changed. It's not because the data is anywhere different or cleaner. It's because it's much more data, and you can now execute it at 100 to 1,000 times faster on special hardware. So the fact that you have hardware available today that can process in parallel and at several orders of magnitude faster the same amount of data and execute the same algorithms have really led to this advent. And I think that's just one example. And so research in FPGAs is probably going to become on the rise again. That's my speculations.
That's now we're talking. It's becoming interesting. Yeah. Okay.
What we see is, I mean, on the one side, we all know 15, 20 years ago, we had data management, then it became information management, then it became, let's say, data analytics, business analytics, predictive analytics. Now we're in big data, right? And interesting is, what we see is that, let's say, almost all 100 to 125 years, there's a big change in the industry happening. About 120 years ago, there was the Industrial Revolution. We are now in the Internet age. Interesting is it took about almost 125 years to connect 1 billion people based on fixed line telephone, and it only took 5 years to connect people on the mobile phone area. And I think we are in the middle of this age. We are talking about this already since the last 10, 15 years. What we see is that we are now in a possibility where more and more devices talk to each other. That goes in the direction of Internet of Things. And just imagine one example. Maybe everybody of us has a coffee machine at home. One example is in the morning when you wake up, you're a passionate coffee drinker, you use an espresso, you always prefer the green taps, then you go and drive to work, and your wife also wakes up, she takes the last green tap, and the next morning you probably will run out of. So just imagine this this idea that the coffee machine is connected to the internet, talks to your watch, to your smartwatch. The smartwatch is connected to your car while you are driving on the way to the office. This might be connected to a marketplace like Amazon, where they're checking, hey, where's the next supermarket on my way? This might be connected to a smart city solution, which shows you where's the next free parking space. You know, in front of a supermarket where there's the cheapest coffee powder, you go in, you pay maybe with your, you know, fingerprint or something like this, and then you get, at the end of the day, your coffee powder, you don't have to worry. So this is just an example, crazy.
So much technology just so the user doesn't worry about the green-capped coffee.
The thing is, how this exists already.
Exactly.
Someone's already connected to the car.
Yes.
We're already delivering into the booth.
And this is now where the interesting part comes. When the coffee machine talks to the watch, to the car, to the, let's say, smart city solution, there is more and more data generated. We all know this, that it's exploding. And the interesting part will be in the future, which comes to the machine learning, what if these systems will talk independent to each other, right? Because not with an interruption of us human being, and there's some intelligence in them. That's what we see as the next wave. Yeah.
Okay. If you had something to add, you can. Yeah.
Well, I think if I kind of go towards the machine learning aspect of the question, so I break it down to two pieces. The first one being the machine learning algorithmic advances, and the second being the type of people/talent that might be interesting. I mean, it's hard to really be accurate here, but given all these trends that are happening. But I think there is, I mean, deep learning is very interesting in that it works. So if I use the analogies that Professor Wapnick used yesterday, with smart engineers, you can get great results. So as a result, it could work. But there are other domains, and like, for example, in AIG, we work particularly, I mean, in the commercial insurance. You cannot go to a big client at the scale of a multi-billion-dollar company and say, you know what, we are going to increase your premium, or we don't like you as a risk because an algorithm said so. You need to have the deep understanding.
Closer to the mic. Everything else is beautiful. It's very interesting, yeah.
So you need to have a very deep understanding of why the algorithm said so. That's why the other camp, which Professor Wapnick and also Bernard yesterday were talking about, become very interesting, like causal inference, the algorithm that can basically have some sort of explanation behind them, regardless of the size of the data. Those algorithms could be very interesting because that give you a narrative in terms of why. So in healthcare, for instance, that is very important. In big commercial B2B type situations, that becomes very important. Whereas in mass market B2C, where you've got millions of customers a day, and the worst case scenario is you're going to lose a customer, like in, for example, a search result or whatever, probably the deep learning approach or likes of that you don't care too much about mechanism, you might be better off with those sort of stuff. Sure. So I think these two camps still will be interesting. Another machine learning kind of field that is brand new in a sense that is creating some kind of communities around it, which has come from topology, is topological data analysis. And it's quite interesting. I've seen some very interesting works around it. I personally, my team, I'm trying to learn more about it and try to see how we can apply it. But it's very interesting, and based on the overall results that you see, it's one of those things that kind of does a very good visual machine learning in a sense that it can come up with the fundamental topology underlying your data cloud. Yeah. So there are some success stories from it in biology and finance and in a couple of other applications. So I hope to see more of it as maybe a parallel third camp in the machine learning community. And all these, I think, if you go back to the type of talents that could be interesting, I don't think we are at a stage that we already kind of managed to get the talent pool that is required for the machine learning. And I think the core of it is those who can execute the machine learning ideas into software. I think still very rare. I mean, you cannot find the brilliant scientists who can develop the best Bayesian algorithm and yet be the best Spark programmer. So I think that's the part that we still need to see better. It can happen in two ways, either by making big data computing more trivial, or by academics and scientists getting more curious about the software side of the thing. The other part is the type of scientists who can speak the language of business. I think that's very important. Because
it goes again about the interpretability of the result.
Yeah. And also, like, I mean, in a lot of the time we understand, like if somebody tells me I applied this machine learning solution to this data and this is the result, the way we normally think as scientists is that we say, okay, the mathematics of it kind of sensible, the backtesting result kind of acceptable, so we are in a positive range of acceptability. Whereas in the industry, it's not necessarily the way thinking happens. They really want some sort of better explanation of, for example, I understand the business dynamic, this is a simplification of the mathematical algorithm that I have, they can work together and multiple rounds of those sort of conversations. So I think having academics and scientists who can speak that language will become a very interesting trend in terms of the talent that real-world machine learning requires.
It correlates greatly with this statement that people tend to trust people that we heard today in the morning. Yeah, people sort of need to have something, at least human-like, that that could explain them something.
Absolutely.
All right, so it's hard to be the lost in this issue, but at the same time, when we have 4 experts and everybody's trying to come up with something new, then the chances that at least one would be right in future are increasing.
Well, just to bring you the view of the telecommunication industry, I mean, I mentioned quickly before, one of the biggest challenges of mobile operators is how to manage the growing complexity of managing networks, which are becoming more and more complex. And of course, the ROI is also lower and lower for mobile operators. So how do we manage all this complexity by also adding some cognitive algorithms into the network nodes? So that's one of the biggest challenges from a telecommunication perspective, how we build this intelligence within the network in order to manage it in a better way. From a marketing perspective, we're working on problematics like churn detection, next best action, fraud detection. So these are the challenges that we face every day in order to make sure that we can provide a better service to our customers. And we also have a B2B activity, and what we see in terms of growing demand of machine learning and data analytics solutions is especially in predictive analytics, predictive maintenance specifically. So we do a lot of work today with the transportation industry, for example, in order to come up with solutions that can enable them, like for example, a train operator to detect, prevent faults into trains and better operate the service for their customers. So, we have this B2C and B2B view of the market, and of course we have internal challenges that we need to face in terms of machine learning.
But do you agree with this framework that Reza mentioned, that B2C and B2B market have very different demands, so to say, in terms of the algorithm that you need and the quality of your prediction in some sense, and interpretability of it? Do you also have this problem that with B2B you have to be highly interpretable?
But at the end, the work we're doing on B2B, it's always to help enterprise solve day-to-day problems that they have with their customers. So at the end, it's always a B2C problematic, but we are, let's say, there as an enabler of solutions for our enterprise customers. So we're always talking at the end about B2C problematics, but it's just with a different, let's say, positioning from a telecommunication perspective. So not as a provider of solutions to end customers, but to provide solutions to enterprise customers.
I see.
I think Reza raised a really good point. Just to go beyond interpretability, I think one practice that happens, or one observation happens a lot in practice, is that you learn a model with machine learning techniques, which are primarily learn correlations. So there are statistics at scale. And then it's very known that you see a 2 or 3% lift in the clicks on search results or the clicks on ads. You put them live and it's a 0.1%, neutral, sometimes even negative. But because the models are not causal, so I think it's not just the interpretability, it's the fact that when you change one of the inputs as a result of the prediction, you need a model that has the ability to be causal rather than just correlated. Meaning, as long as you don't change the input, so your system never takes an action, that was what the prediction was conditioned on, I think that's okay. You summarize. That's you're not doing much harm. But even in a B2C scenario, if you start to change the placement of the ad, or change the position in the search ranking of a result, you are going to change the input distribution significantly. And today's practice is that people, the one I know, is they learn offline models, and if it looks positive, they cross their fingers that some of it translates into real lift. Meaning that the correlation is not the elasticity that actually is observed. And that is a problem, I think. And the econometrics field has some methods to do this at very small scale, a bit like statistics in the late 70s had techniques, but it didn't scale. I think probably scaling of econometric models, modeling techniques is also an emerging field, not just for interpretability.
But was it so like machine learning scaled naturally because it was successful? As you mentioned, you just applying the algorithm, you get immediately on. I really like the formulation that Professor Li Deng gave on the first day, like success on industrial scale. So machine learning as a method was a success on industrial scale, but from time to time there's always a method that claims to become next one, but somehow it's either not that promising or too hard to implement or something like that, I guess. Yeah.
I think there's even some science. You even have to develop some of the methods that scale. Right now, it's a very human, labor-intensive and domain expert-intensive process to do causal modeling, and nothing that is semi-automated. And then success, I think, success definition is relative to where you are.
Yeah.
So machine learning success doesn't mean it's like solved all the problems. It was just better at anything we could do manually. So causal models probably also not getting us exactly to sort of perfection of prediction. But I think they're going to get us to having to do less experiments. And then instead of crossing the fingers and hoping for the best in an A/B test, you start to have guarantees for an actual lift that you're actually going to see of a predictive model.
Okay. So we've discussed the talents. We've discussed the issue of the fact that science is a basement of, like there is a science part, there is an engineering part that some of you briefly mentioned, then you combine them together and eventually you give the product to the user or to the consumer. And just to kind of summarize that, some example of your product that you work with that comes to the consumer directly, so the output of machine learning that I don't know, not me, maybe even me, but just the person on the street that can see now as an output of machine learning, maybe not knowing that it is actually a machine learning based recommendation or machine learning based, I don't know, tariff plan or something like that. So out of your business, could you give just one or maybe two examples of these solutions? Yeah, maybe we'll start with somebody who didn't start before. So maybe either Reza or Jochen. Reza. Okay.
Yeah. So I'll not be able to share maybe some of the cool stuff that we are doing in AIG, but I can generally say about the past experience. Some of them could be AIG, some of them could be elsewhere. Like, for example, a very interesting one of the first machine learning...
You'll say about something cool and we will assume that it's not from AAG.
Let's see how it goes. So one of the interesting things we did in healthcare was, let's say that people have come to hospitals and they have different bills in different departments. And there is this problem that there's a revenue leakage in hospitals where some of the bills get lost. Okay. So we had a very good recommender system in place. So we basically represented the problem as a recommender system problem, right? We used to say, similar to if you like movie ABC, then you're likely to like D because everybody who liked ABC also liked D or something like that. You can simply say if you had bill ABC, then probably you had bill D because the bill D happens to be in the list that had ABC in their basically bill list. So as a result, that helps a lot of healthcare institutions to make sure that instead of human auditors who make a lot of mistakes and also they're not adaptive to this change of organization and so on, that could change the dynamic of leakage of the bills and so on. These algorithms are quite good in picking it up and also changing over time as the data changes. Or there are plenty of usual models around customer retention, cross-sell, and a lot of other things like that. But I think the very interesting thing that is very applied and can be useful for a lot of fields is around, for example, drones and computer vision. Like, for example, you can start using that for a lot of...
That definitely sounds like an expertise of AEG.
Well, I mean, AEG can use it as well as a lot of other industries, where you can basically use a lot of interesting machine learning that have been developed around computer vision to basically monitor things. Like, for example, say, let's just go for insurance, right? Let's say in insurance, you can simply say that you're insuring a big construction site. Yeah. Then if you want to see if a person is wearing a helmet or not, you can put a bunch of people around watching people and saying, oh, that person is not wearing it or not. You can have basically a video camera or a drone watching the construction site. If the construction site is big, the human solution is going to be very costly, very inaccurate, and so on, whereas a computer vision base is going to be much better, especially with the superhuman performance of computer vision. So the list of applications can go on, and there are some that we did, there are some that could be applied in the fields that we have been in. So,
okay, some other examples, and then we'll move to the questions. I know that there are questions in the audience. I just want to finish with the examples, and then, yeah.
So I think first, before giving a few of the 15, 16 years that I've worked in various companies on applications, there's an excellent book that recently was published that has actually lots of applications. The whole first chapter describes sort of a day in the life of everyone, and points out which parts are all, which parts of this experience are all generated by machine learned model, and it's absolutely staggering. So the book is called The Master Algorithm by Pedros Domingos. So I can, for people interested, where in the real world today in my life are machine learning models used, I recommend that book. So probably one to give that's not as obvious. How many people here have shopped at Amazon.de or com? Quite a few. So I think one of the premises is you have very low prices. So that sounds easy, but when you think of it, we have about 20 million products that we buy and sell. So in order to set the lowest price, we need to find what is currently the market price for that item. With 20 million products, you can't separate it out and say, well, let's hire 20 people and have each of them hourly check the prices, the latest prices for 1 million products. So that's something where machine learning is used. Okay. Where a predictive model goes out and tries to find, it's not just crawling. Sometimes you have to fill in for products that no one else lists, but that are very similar in the description. So that's a machine learning model.
Okay.
Second thing, how many people here have a Kindle? So has anyone ever clicked the X-ray button when you read a book on the Kindle? So on the X-ray, there was not so many. If you click that button in the top bar, what you get is you get an index into the book that is by the people that are mentioned in that story. So if you have Game of Thrones, you have Khal Drogo and Targaryens and Lannisters.
So you can eventually understand what's going on.
Yeah. So you see them mentioned. All the ones you see basically all the ones that are mentioned on that page, or the ones that are mentioned in the book altogether. You see all the places they're mentioned. You can quickly jump there, and you see the reference to Wikipedia if they have a Wikipedia page or a Shelfari page. Now, for a few books, you could probably do this by hand, but in reality, a lot of this work is a semi-automated process where we use machine learning to predict which tokens, which words in a book, whether it's French, it's German, it's English, it's Japanese, it's Chinese, is actually a beginning and end or a middle of a organization of a place or a person. That is a machine learning process because of the sheer scale of data. And again, people probably wouldn't have thought that. It's a neat feature. It's a pre-processing feature, but in order to scale, machine models get used. And in the last example, how many of you have ever played on Xbox Live? This is the video gaming service. This is amazing. I often talk, and usually 2 or 3 hands go up, and afterwards 20 people storm to me when I tell them where it's used. So for those that have heard of Halo 3 and games like that, so every single time you play online in these video games, and you finish a game with your friends, where you played in a team with them, or you played against a bunch of friends that are someplace else in, I don't know, live in Hamburg. That outcome of the match, which person was playing in which team, and which teams came in first, second, third, or fourth place, is fed into a predictive model that updates a latent variable called skill in order to predict the probability of winning of every player that's currently online when playing against every other player, so that the matches get created by optimizing towards 50% chance of winning, losing. That is a machine learning model at work, constantly matching 1 million people each day, and that's an example that probably isn't that obvious.
It isn't, but it's good that we learn about it. So some more examples that we can.
Yes, maybe. Yeah. I would like to try to connect the dots from the scientific discussion into the business discussion, as the topic is big data in the real world. So all companies like an Airbnb, right? Biggest hotel company in the world, not owning any hotel. And or companies like Uber, biggest taxi company in the world, not owning any taxis. So the interesting thing is all of these new business, I call them disruptive business models, right, based on data and information. And I wanted to share one example with you, what we just recently have done, because we are in Berlin, and they launched this about 2-3 weeks ago in the street of Bundesallee. We worked together there with Siemens, the company, for a smart solution. They put a radar sensor into the street lamp, scan down on the street, and get a radar picture back, so visualization. And they have written a software which takes this graphic analytics and can predict, you know, if there's a free parking space, what's the size of it, 2.30 meters, is there a child playing on the pedestrian, what's the traffic, you know, how many cars are driving around, etc. And the business idea, as you can imagine, it was a technical discussion at the beginning, R&D, but interesting became the whole discussion, as we said, what for business models can we apply to this kind of service, right? Okay. Because it's data and information, you do analytics out of this, so what can you do with it? How can you make money with it? And then we had discussions, it's very obvious, when I'm a citizen driving around, want to find a free parking space, I don't want to cross the corner 5 times. You know, I want to see on my app where's the next free parking space. Saves time, pollution, energy. We even had other business models where we said in a city, like a Starbucks coffee or any other retail shop might be interested to offer free parking space to get more customers in, right? And then we even came to the idea there might be a lot of citizens living in a city, they go in the morning to work, and they might have a parking space or a parking garage, they could rent it out, right? Okay. You might have an app, a service. And then we had a discussion with Siemens, like Siemens could become the biggest parking space provider in the world, not owning parking spaces. So this is the connection about what you can do with data information to new business and disruptive models, which I think is quite an interesting part.
Okay, I'm sorry because we're running out of time, so let's move to questions. Since we have a lot of different expertise in different fields, that would be good if you also name the person if it is a question to a particular person. So either Emanuele, Reza, Jochen, or Ralf. So please, if you have something to ask, it's time to do that, because we have like 10 minutes left maximum. Any questions? I still have, but okay, yes. Could you? No, the microphone is coming. So we have Emanuele, Reza. I'm naming them in order of. Yeah. Okay. Emanuele, Reza, Jochen, and Ralf.
The question is to Ralf, and it relates to the topic of talents.
Okay.
Do I have to present myself once again?
Yeah. Well,
I'm still Uri Degen from Israel. Yeah.
Nothing changed so far. Yeah.
You mentioned the need in scientists who would enhance the capability, the computational capabilities. Yes. Did I get it right? So my question was and is whether the exponential growth of computing power and of storage doesn't eliminate need in such talent. And by the way, I have also my own opinion on it, but I would very much to hear yours.
So just let's see if I understood the question. So you're saying what I was saying about the scale of data becomes, the amount of data becomes grows a lot exponentially with let's say every 18 or 20 or every 24 months. That if machines were getting the accuracy, it eliminates the need for people that do these jobs today, or?
No. Okay. This is not what I mean. Okay. What I mean is that indeed the computational complexity grows, but the available CPU power grows also exponential. Of course, the question is how long will it continue? But so far, it continues exactly like this.
Yes.
And the question is whether the very fact that we have this brute force, if I once again connect to the notion of Professor Wapnick, doesn't eliminate the need in ingenuity in this particular field.
So I think it, if I can answer the question right, then the question is it just simply scaling simple algorithms up, such as, I mean, I think I was sort of saying in neural network learning, nothing has changed except that it's now executed faster, but the algorithms have been the same. And I think if I understand your question right, does that mean that we're simply looking at scaling up simple algorithms rather than having the algorithms grow in complexity as well? I think there's a big factor to this. I mean, when you look at the basics of linear models, they're often primed as not very accurate and not very effective. Is that okay? But I think scaling up isn't a simple process, because when you scale up beyond the single machine and against an execution framework that is not sequential anymore, you have to deal with inconsistencies and the inconsistencies in the state. Is that okay?
No, that's fine.
Okay. The inconsistencies in the state is something that you do need to take care of algorithmically. So while the mathematical model continues to stay simple, like a layered architecture of pseudolinear functions, like a neural network, or bilinear functions, like in recommender models, or linear models with a fixed transformation, like in kernel algorithms. The moment you lose consistency because you go into a distributed architecture, whether it's in hardware and software, you do have to become inventive on how you synchronize the state as quickly as possible. And I think that one does require algorithmic inventions, even though the mathematical models will stay simple.
Okay, the next question. Yeah, there is one. Could you? Yes. This one, please, and you can just take one of these mics and yes, no problem.
Should I go ahead? Okay. So maybe I start. And this is Norbert Wirth from GfK. I'm heading up data and science for GfK Group. It's a question for the entire panel. So when and from a practitioner's perspective, when I speak to the guy who's heading up my data lab, and I say like, hey, data scientists, what profiles are we actually looking for? And he's a young, strong-minded person, right? He says, forget it. The data scientist as an individual doesn't exist. It will always be a team play. I'm wondering what you guys think about this. Is it really true? What skill sets are we looking for from an industry perspective if we're hunting for data science talent?
Okay.
Whoever wants to take it.
I think,
I think
sure. It is as any other thing in the industry or anywhere else, really. The team, of course, is a good thing. But that doesn't mean that I didn't understand exactly what the implication of what you said was, in that we shouldn't care much about what talents each individual has because there's a bigger team that compensates for it. But I assume that that's not what you implied.
No, the question really is, what skills are you actually looking for? Are you looking for the one individual that brings it all together? Or do you accept the fact that you need multiple people who complement each other?
Oh, definitely. I mean, like, if it depends on the scope of the role that the data science team, the corporate structure determines what role goes where. But if you've got a team that is supposed to be self-sufficient from idea to prototype or idea to product, then the nature of skills within that team should be ranging from, I don't know, algorithmic type skilled person, implementation type skilled person, to DevOps and product development, front-end, back-end development, product architects from large-scale inference to fast computing. A lot of these things matter in that team. Like, but if you just talk about, for example, the type of data scientists who are like machine learning-y, I recently advertised a role that had like 2 pages, like 1.5 page job description. But when I wanted to talk about it on my LinkedIn, I basically said it in half a line, which is I'm looking for a data scientist with R, Spark, Python, and large scale inference skills. That's basically it. So that pretty much summarizes 80–90% of the skills you need. But when the product comes to play, then they need to be able to kind of think API, think basically new ways of user experience, which is dramatically changing. And also, a big thing that happens is that originally when data science teams were created in the business, they were normally being fed in terms of thoughts and ideas from the business, and they were kind of translating it to a machine learning or software solution. Now I think there's a new mandate about them being disruptive and new thinkers in the business. Like a lot of interesting projects that we do in AIG sometimes come from data scientists thinking out of the box, because that's where insurance industry could be disrupted. Like a lot of startups that started 2 years ago and are valued at $2 billion or because people thought out of the box in insurance, like Oscar Health and others. That's why I think you need the type of data scientists who are willing to kind of go out of the box in terms of their thinking, who are skilled across the usual skills of programming, in larger scale inference, and algorithmic way of machine learning, and then also be willing to work with people who can do APIs and end-to-end products.
Okay, I'm sorry, we have just time for one question. Let's assume that was more or less detailed answer, and then, please.
Ralf.
Could you introduce yourself?
Yes, I'm Sergey Kravchenko. I'm vice president of the Boeing company. Okay. Ralf, you are the head of machine learning for Amazon for the whole company?
For Europe.
For
we
Europe
have
only.
3 such positions in India and Seattle, and here in Berlin for Europe.
Okay. So I am based in Moscow and in Seattle and lived in Seattle for a long time. So I watched Amazon actually from the very beginning. It was created as the internet logistics fantastic company. You know, your founder challenged the, using his terms, dinosaurs. You know, he talked about Walmart, but I can, imagine that maybe he thinks about Boeing or United Technology or GE as a dinosaur also, as the companies that are going to die. You know, he talked about Walmart, that Walmart will die soon because they don't use the technologies like big data and machine learning. So, 5-10 years ago, we couldn't imagine that Google, Amazon, Tesla will go in aviation and space, will challenge General Electric, Boeing. So what I was always interested to ask Bezos, and maybe I will, if I will run into him, is that what are the chances that all this knowledge and experience that you guys collected in the last 20-25 years at Google's, Yandex's, Amazon's, Tesla's, on this fantastic disruptive technology that completely changed the way we live, completely changed telecoms, retail business, will be transferred fast into this dinosaur industries, and we will design space engines, like you want, or space vehicles, or drones like Google, and aeroplanes, different way. So the question is, people who run machine learning for Amazon, or for Yandex, they absolutely vertically professional in search engines. They do it the best, or in retail, internet operations. Are you guys brave enough to step into dinosaur industries and change them too?
And please, answer in 1 minute.
Answer in 1
yes
minute.
or no.
I
It's
see.
yes or no question.
Okay.
Are you brave enough? Just go for it.
I think the short answer is yes, but yes, but the one thing is, I kind of requires two ingredients.
This is a big problem for the world.
It has 2 ingredients, I think.
So much
Is it the problem that they're ready to go?
If you say yes, then the safety of millions of people is in jeopardy.
No, so I think...
Okay. I think that's
No, you got to give me one more sentence.
Okay.
So I think it requires 2 pieces. One is people, education of people in that new skill, and I think the previous question was kind of hinting at that. What is the skills that people need, whether it's in dinosaur industries or it's in emerging industries? And then there has to be tools. And I think where we can contribute a lot is the tools as a company, Amazon. So tools like cloud services and client tools that we offer. Education is one, I think, where society needs to step up and kind of make it, and we have MOOCs already, we have training classes, and we bring it into the curriculum of people. The training of people will take longer than the tools, but I think you need both. So I think it'll happen, but it won't happen next year. The tools might be there, and there's some tools already, but the education of people is the bigger one.
I think that's a very good sentence to finish on. The education of people is very important. Thanks a lot for attending this panel. Thanks a lot for coming to it, and we have a coffee break, as far as I understand.